In financial maths, there are a series of equal payments made at regular intervals, which means if you are, say, for example, you are investing money, right, say with Old Mutual. When you go to Old Mutual to sign your paperwork and say, I want to open an investment account, then you then agree that every month you are going to pay a specific amount for a specific period of time, right? That payment or deposit, it doesn't change whether there is inflation or not. It remains the same, and you pay it over a specific period of time. That's an annuity. Also, cases like borrowing money from a bank to buy a car, to buy a house, and so on. When you are repaying, you only repay a constant amount, okay, throughout the entire time period, right? So the annuity formula, there are about two of them. Examples of annuities, we have got savings, right? We have got retirement annuities, right? And we also have the most common cases, that is the home and vehicle loans, right? So when you're doing calculations for annuities, there are two types of annuities. We have got what are called present value annuities, right? Present value annuities, so I say types of annuities. Let me just emphasize this. So we've got two types of annuities. Now, in all those annuities, there are equal payments that are made throughout, right? The payments, they have to be made at regular intervals. So you can't skip it, right? You can't skip it, right? The interest rate remains fixed. It doesn't change, right? And also, generally, we use the compound interest formula to do the calculation. But they've got their own formula, which I will introduce just now. So types of annuities, one, we have got future value, which is one that I will start to talk about just now. Future value annuities. Generally, these ones, they involve investments. Okay? All future value annuities involve investments, like a retirement annuity fund, pension funds, and all those things, right? Okay, then we have got what are called present value annuities. Now these ones involve borrowing, right? Like vehicle loan, car loan, and so on. So here I'll just say loans. Right? Now it's very important for you to know the difference between the two, because the two formula which I'm going to talk about, they are almost the same, and you can use the incorrect formula again. So you need to know that difference. Right? Like the other thing, okay, I've had the experience of marking um, at the Matrix Center a question on financial maths, and I saw lots of things being written. Right? So I'm going to share my experience as I move forward. Okay, in 2018, I marked the question of financial maths, and I saw lots of things there. All right. So we start with the future value formula. Okay. Before I carry on, it is very important for you to know that future value involves investments, savings, okay, not loans. How do you know that it's future value? Number one, there has to be, in the question, there must be a clue that money was being saved. Also, there was a specific amount of money which was being deposited at regular intervals. That would be an annuity. Now, there is a mistake which can happen where someone can end up using this formula when you are talking about an annuity. All right? So I'm also going to talk about the difference between this formula and the one that you see here. There's a difference. And there's a temptation to use this formula here when you're supposed to use this one. Right? That's why you have to know the true definition of an annuity. So with the future value now, what happens is a person goes to a financial institution. They open a savings account, either it's a bank or it's an investment firm like Old Mutual. Then they agree to pay a specific amount of money, or rather to deposit, to save a specific amount of money over a specific period of time. If it's monthly, for example, it means the person will deposit an X amount there, then another X, 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 X. Throughout, it will be the same amount. It doesn't change. In most cases in real life, a person will organize a debit order so that on a specific day every month, that amount is taken out of your bank account. Right? If you decide to pay cash, then you must have that cash of that specific amount deposited. Right. Now, this formula, it comes from series. Right? Okay? It comes from series, but we don't really not need to get into the details of the derivation. So the formula is F standing for the total amount. That is the accumulated amount after X amounts have been deposited. Okay? So this is the total amount after a specific period of time. Let's say you decide to save money for 10 years. After 10 years, the amount that will be in that bank account, that large amount, is F. Right? So it's X, open square bracket. So X is multiplying everything that's inside the square bracket. Inside that square bracket, you've got the circular bracket where you've got the compound interest part, which is 1 plus I raised to the power of n, all minus 1. Alright? And then that product, you divide it by the interest rate. So your F is the future value or the total amount in that account or that investment account. X is the payment, okay, which is done every month. Like for example, if you got a car through a vehicle loan, means every month, right? The bank, either it's West Bank or ABSA, FN, NetBank, their loan division which does vehicle finance, they will take an X amount from your account. If you default, right, usually it has got consequences. You end up having to pay more interest. Then I is the interest rate which you agreed, and this interest rate doesn't change. It remains constant throughout. Then N is the number of payments. Now this is very important. N is not the number of years. It is the number of payments. How many payments you are going to make. Now, also, later on, we are going to need to calculate N for this formula. And we need the concept of logarithms as well to do that. All right? Okay, that's what you have there. Can you just copy down quickly, then I'll do an example. All right, so the question says, Lebo decides to save 200 Rand per month for the next 3 years to create an emergency fund for unforeseen circumstances or unforeseen expenses. She makes the first deposit immediately. That word immediately in financial maths grade 12 is very, very important, this word. Right? That word immediately. And the last deposit at the end of the 3 years. Interest is calculated at 8.7% per annum compounded monthly. How much will she have saved up by the end of the 3 years? Now, I don't want you to get tempted because you saw this, then you think you are going to use the compound interest formula, this one here. No. It's a big no, no, no. Right? It's an annuity because 200 Rand is going to be deposited a month. There's an equal payment which is being made at regular intervals. Therefore, don't use that formula. From now on, when you're answering questions in financial maths, you must ask yourself, are there any equal payments being made at regular intervals? If the answer is yes, and it's a savings, you're going to use the formula which I'm going to write just now. If the answer is a no, then you use that formula. You can make a mistake using this formula. And you can come out of the exam and say, I got that, and it's not correct. Right? So here, let's list what we have. We don't have F, right? X is going to be 200. That's the amount which is going to be deposited at regular intervals, which is per month. Our interest rate is given as 8.7% per annum compounded monthly, so that is 0.087 over 12, right? Our N, now our N is not the number of years, it's the total number of payments. Now, I forgot to remind you that a timeline may be required here, so I'm going to do the timeline. Well, that timeline will help me to determine N. The timeline will help me or help you to determine N. So the timeline for this situation is going to look like this, right? Since an amount is going to be deposited immediately, that is on the day that the person signs the paperwork, which is T0. So an X amount is deposited there. Then at T1, another X amount. Now, in this case here, based on the number of years, it will be 3 years times the compounding period, which is 12. So we get to T36. Okay? An amount is made immediately. Also, there is a final payment which is made here at T6. So the question will be, what is the total number of payments? The total number of payments is not 36, it's 37. Because an amount was made immediately at T0. So if you count 1, 2, 3, 4 up to T36, you get N plus 1, which will be equal to 37. So this will be 37. You can make a mistake here of putting N equal to 36, you get an incorrect final answer. That's also one major issue with regard to the grade 12 financial maths. The determination of the number of payments. All right? Are you following that? Yes. Okay. If you are depositing immediately, okay, let's say you go to, I'll give you an example of a year. Right. Let's say a person deposits money on the 1st of January, and then at the end of each month after that, what will be the total number of payments? To be 30. Because you have to count the first one. It's done at T0. Or rather, if I ask you how many numbers are there between 0 and 5? How many numbers? Yes. 6. So here, the first payment is made at T0. It's not made at T1. If it was made at T1, up to T36, then the total number of payments will be 36. But here we have to include the first payment because it was made immediately. This word immediately means T0 is counted. So you made 2 payments in 1 month. Yes. It means the first month in that case, in the case of January, first January make a payment, then 31st of January make another what? Payment. Total payments for the year, 30. Right? So the formula is F equal to X times 1 plus I raised to the power of positive n minus 1 all over I. Okay? Then we are going to substitute now. By substituting, our F is going to be equal to 200 times 1 plus, that's 0.087 over I, sorry, n, which is 12. Right, be aware that this must be inside the circular bracket. Our n here is 37. Then we subtract 1, close the bracket there, and we divide that answer by 0.087 over 12. Right, I'm sure you can see that the formula, it's a little bit hectic, right? You have to know your calculator very well to work with it. So, after this now, then let's put that in the calculator. Now, when you're putting in the calculator, please, because of the fact that this formula is a little bit complex, you need to know how to do it. And the only way is by factoring. So first thing, I'm going to put my fraction option. Alright? My fraction option. The good thing is your calculator can accommodate it. So we have 200 times, now there are two brackets, I'll start with the first one, then the second one, open the first and second, then 1 plus fraction option of 0.087 divided by 12. Then I'm going to close the first inner bracket, right? Then I'll subtract 1. Okay, I didn't put the NY, I'll put it. Then minus 1, then I'll close the bracket. I forgot to put the N there. So fortunately, I can put it, right? So N is 7, right? Then I'll come down to the bottom. I'll go to fraction again, 0.087. Don't be a spectator. Don't be a spectator, right? Better you do it. Because if you don't practice, then you might have issues when you're on your own. So the answer there is going to be 8,452 and 67 cents. 852 and 67 cents. So F is going to be 8,452 and 67 cents. This is in rand. So this will be the future value or the accumulated amount after those 3 years. All right.